Okay, so this is multiple choice Monday number 4. If you haven't already answered this question, just pause the video now and have a go at answering it on your own before I go through the answer and the explanation of how we get to the answer. So how did you get on? The answer is B. 2H plus CO3 minus makes H2O and CO2. Now, to be able to answer this and not just be guessing, we need to know a couple of things. We need to know a little bit about the nature of an acid-base reaction, and we also need to know a little bit about ionic equations and basically what we should be including in an ionic equation and what we should be taking out. So an ionic equation, if you look it up, it will just tell you that you're writing a full equation and you're removing spectator ions. But it's not always perfectly clear what a spectator ion is, and it changes depending on the nature of the chemical equation. So if I was doing a redox ionic equation, then a spectator ion is an ion that doesn't change its charge or oxidation state. So I'll write oxidation state. You may not have done that yet. So for example, if something just stays -1 all the way through the compound, I won't include it in my ionic equation for redox. If I was doing a precipitation where you get a solid from mixing two solutions, then I don't include the ions that stay in solution, i.e. the ones that are not part of the solid precipitate. So how do I apply this to acid-base reactions? What should I remove and how do I know what to remove in these equations? Here's my full equation. So this is following a general thing that we've been learning maybe since year 9 actually, about acid plus a metal carbonate makes a salt, which in this case is calcium chloride, plus water plus carbon dioxide. So this isn't a precipitation and this is not a redox reaction, it's acid-base. There's no oxidation number changes happening here. So what I'm going to look for instead is any changes to maybe the bonding, not necessarily the oxidation state, but maybe things that were charged are now not charged or vice versa. So I need to look more detail at each of the substances and decide sort of how they were bonded, what they were like before the reaction and what they're like after, so I can see what's genuinely changed and what hasn't really changed. So we should know that when an acid goes into water, so HCl is a covalent molecule, it's a gas, but when we put it in water, we split it up into hydrogen ions and in this case, chloride ions. So it becomes separate ions. I can treat calcium carbonate the same way, so although it's a solid and it doesn't dissolve, I can still think of it as being made up of, in the lattice, calcium ions and carbonate ions. And then my calcium chloride is also an ionic substance, so on the other side I can also see that I have calcium ions and two lots of chloride ions. But then when I get to these two substances, water and carbon dioxide, they are covalent. I can't split those up into ions. Now I know water does split up a tiny amount into H plus and OH minus, but that's really only a very, very, very small amount. And CO2 does not split up at all. CO2 is a gas which is released in this reaction and gives us the bubbling. So now when I look at each side, what I should see is that I have some ions that are changing and some that are staying the same. So if I look at my calcium ions over here, they're not really doing anything. They are calcium ions on the left and they're still calcium ions on the right. Their bonding hasn't changed. And my chloride ions also have not changed. In fact, they have just remained in solution the whole time. I get the same energy change in this reaction if I were to use nitric acid instead of hydrochloric acid, and that's because the hydrogen ions are already released into solution, so it makes no difference to the energy change. That means that I can cross out the chloride and the calcium. So what you're removing, to get to from a long story into a very short one, when you're doing an acid-base ionic equation, you want to remove the salt. The ions that are in the salt are not part of the ionic equation. So my overall equation is going to be 2H plus CO3 2 minus goes to H2O plus CO2. That's the chemical change that's happening. So if that made you realise that you need to know a little bit more about ionic equations, balancing equations, acid-base and redox, all those sorts of things, you might be interested in my free online course, which is Essential Equation Skills. It's completely free for as long as you like to look through it, and it goes through ionic equations, acid-base redox reactions, precipitations, half equations with balancing electrons, all that kind of stuff, just to really get you a good grounding in that area, which is often skipped over at A level. As also some practice exam style questions and some more explainer videos on my website, ckchemistry.co.uk. And of course you can follow me on Instagram and Facebook, and I'll give you more A-level chemistry tips and revision materials every week. If you're interested in the course or visiting my website, you'll find the links in my bio.